Hi, this is Math 6, Lesson 3-6, Generating Equivalent Expressions. In this lesson, you'll be able to identify and write equivalent algebraic expressions. You will also justify whether two expressions are equivalent. All right, let's look at exploit it. 2-1 says all three expressions are equivalent. We got 8n plus 6, 2 times parentheses 4n plus 3, 14n. All three expressions equivalent. Find the value of each expression for n equals 1. Okay, let's plug in 1 for n. If n is equal to 1, would we get the same answers for all three expressions? Let's see. 8 times 1 plus 6. 8 times 1 is 8 plus 6 is 14. 2 times 4 times 1 plus 3. 2 times 4 times 1 is 4. 4 plus 3 is 7. 7 times 2 is 14. Okay. 14 times 1 is 14. Okay, so we do get all the same answers. How about when n is equal to 2? When n is equal to 2, 8n plus 6 is 8 times 2 plus 6. That's 16 plus 6, and that's 22. Okay, when n is equal to 2, the second expression is 2 times 4 times 2 plus 3. And that's equal to 8 plus 3 times 2. And 2 times 11 should be just 22. Okay, so far we have the same answer as well. And the last one, 14 times 2. What's 14 times 2? 28. Now we have a different answer. Okay. Do you think all three expressions are equivalent? Do you agree with Chuan that all three expressions are equivalent? Explain. How can we explain using the process we just did? Chuan is incorrect because only 2 of the expressions are equivalent, right? Using the distributive property, 8n plus 6 is equivalent to 2 times 4n plus 3. So they should be the same, right? Because if you multiply the 2 out, you get 8n plus 6. But is it equivalent to 14n? No, you cannot turn 14n into 8n plus 6 or 8n plus 6 into 14n, right? So let's write that down. Chuan is incorrect because only 2 of the expressions are equivalent. Okay, this is how you explain it out. Focus on math practices. When a number is substituted for the same variable in 2 expressions, how many times must those 2 expressions have different values before you know they're not equivalent? Explain. Okay. So substituting means substituting a number like this, right? If a variable is equal to a specific number, what is the value, right? That's when a number is substituted for the same variable in 2 expressions. How many times do you think the 2 expressions have different values before you know they're not equivalent? Just once, right? To be equivalent, the two expressions must always have the same value when the same number is substituted for the variable in each expression. If you just have one time where the value is not equal to each other, they're not equivalent when the same value, when the same number is substituted for one variable, you know it's not the same expression, okay? So should be once. Okay. So the same expression should always give you the same value when the same number is substituted for the variable. All right, that is the equivalent expression. So think about how you can identify and write equivalent expressions. Let's look at example 1. Use properties of operations to write equivalent expressions. First of all, equivalent expressions have the same value in definition, regardless of the value that is substituted for the same variable in the expressions. Using properties of operations to write equivalent expressions for 3 times 4x minus 1 and 2x plus 4. Do you remember the properties of operations? You have commutative property, associative property, distributive property. Commutative property is when you have different order for addition and multiplication. If you switch B and A, your answer should not change. Associative property means you have a parentheses, and that's also talking about the order. If you have more than 2 terms, then the order of adding or multiplying, when you have all multiplication or all addition in that expression, should not change your value, okay? Distributive property says when you multiply the sum of 2 numbers, then you can multiply out the number with the 2 other terms you have in the parentheses, okay? Also works for the differences. All right, so using the distributive property and associative property, you can rewrite 3 times 4x minus 1 to multiply them out literally and get 12x minus 3, okay? So 12x minus 3 and 3 times 4x minus 1 are equivalent expressions. They're the same. They're always going to give you the same values when you plug in the same numbers for x, okay? Also, for 2x plus 4, you cannot multiply it out, but you can use the distributive property backwards, okay? So then in order to write 2x plus 4 with a parentheses, you need to look for a common factor of both terms that's greater than 1. So 2x and 4 will have a common factor of 2. Dividing them out, you get 2 times x plus 2. So 2 times parentheses x plus 2 is equivalent to 2x plus 4. Let's try this question. Now let's write an expression that's equivalent to 3y minus 9 using the distributive property backwards, okay? First, we need to find the common factor of 3y and 9. What's the common factor of 3 and 9? It's not 9, it's 3, and it has to be bigger than 1, okay? So we're gonna multiply, we're gonna we're gonna multiply 3y and multiply 3 times 3, okay? We're gonna divide the terms so that we can rewrite them with a multiplication of 3. And then we're gonna take the 3 out, the common factor out, and make whatever we have left in the parentheses. So we got y minus 3 in the parentheses. So 3y minus 9 is also equivalent to 3 times y minus 3, okay? Why can you use properties of operations to write equivalent expressions? Why? Because what are properties of operations? What do they do? Properties of operations allow you to change the order of terms, group terms, or distributed terms without changing the value of the expression. So you can use them to rewrite them in different order, different ways, but really the value does not change. The function will stay the same. So they are equivalent expressions. Okay. All right, example 2. Using properties to identify equivalent expressions. Which of the expressions below are equivalent? We have 3 expressions below. 8x minus 4, 4x, and 4 times 2x minus 1. If you look at a parentheses, you could use the distributive property to multiply them out. 4 times 2x is 8x. 4 times negative 1 is negative 4. Okay? Do we have equivalent expression among these 3? Yes, we have 8x minus 4 as an equivalent expression. Is there any way we could make these into 4x? No, they're already simplified. You can't do anything else. Okay, so 8x minus 4 and 4 times 2x minus 1 are equivalent expressions. Let's try this question. Which of the following expressions are equivalent? We got 10y plus 5, 15y, and 5 times 2y plus 1. Okay, let's use the distributive property to distribute this out. 5 times 2y is 10y. 5 times 1 is 5. Okay, 10y plus y, so plus 5 is already your first expression. So 10y plus 5 and 5 times 2y plus 1 are equivalent. Okay. Example 3. Use substitution to justify equivalent expressions. So justifying means prove. How can you explain how they're equivalent, right? So by definition, equivalent expressions give you the same values when you substitute the same numbers for the variables. Okay, so in order to check and justify equivalent expressions, you plug in some numbers. Are 6 times n plus 3 minus 4 and 6n plus 14 equivalent expressions? Okay, you can use the distributive property to make the first expression simple. Okay, distribute 6 out into your parentheses. And so you got 6n plus 18 minus 4 and subtract 4 from 18 to get 6n plus 14. Yes, they are equivalent. You can justify by substituting 3, okay? Because, you know, if it's 1 or 2, there might be a chance that they're the same, but other numbers might not, right? So usually 3 would give you a difference when you have a different expression. So 6 times n plus 3 minus 4, substituting 3, you get 6 times 3 plus 6 times 3 minus 4. And then 6n plus 14, you get 6 times 3 plus 14. Or you can directly put 3 plus 3 over here in the parentheses and solve the parentheses first. And then you have 6 times 6 minus 4. And you have 36 minus 4. And then you have 32. Okay? So either way, you should get 32. And if you plug in any other numbers, they should all get the same values. So they are equivalent expressions. Okay? So let's look at this try question. Are 2 times x minus 3 plus 1 and 2x plus 6 equivalent expressions? Use substitution to justify your work. Okay, first you can solve it out using distributive property to see if they're equivalent or not. And you need to justify later, okay? 2x minus 2 times 3 plus 1 is 2x minus 6 plus 1 is 2x minus 5, right? Is 2x minus 5 equivalent with 2x plus 6? No, we don't think so. So use substitution to justify our work, okay? We're gonna first say no, but we can say 2 times, okay, we need to say when n is equal to what, right? Because we tried 3, why don't we try 4 now, okay? 2 times 4 minus 3 plus 1, okay? 2x. Okay, why don't we start with the expressions, the original expressions. When n is equal to 4, 2 times x minus 3 plus 1 will be 2 times 4 minus 3 plus 1. And 2x plus 6 would be 2 times 4 plus 6. And that's equal to 2 times 1 plus 1, 2 plus 1, so that's 3. Okay? And that's 8 plus 6, which is just 14. 3 and 14 are not the same. So they are not equivalent. We just use substitution to justify our work. All right. So what did we learn in this lesson? We learned that two algebraic expressions are equivalent if they have the same value when any number is substituted for the variable. You can use the properties of operations to write equivalent expressions. Okay, we used a lot of distributive property in this lesson, so make sure you know how to use distributive property forward and backward. That was lesson 3-6, generating equivalent expressions. All right, I'll see you in the next lesson.